Hello, everyone, and happy Wednesday. As I mentioned to many of you, I was not going to be here today. However, we are still going to move along with lesson 3.3, which is analyzing our evidence cards to really get us set up and ready to go for our written assessment at the end of our unit, which will be on Monday, where we're writing our claims as to what actually happened with our launch system on Wednesday and why it launched so much faster. For today, you are going to need your mini books. At this point, please pause the video to make sure that all mini books have been passed out. First period, you will skip this point since you already completed this on Tuesday. To refresh our memory about what we've looked at the last couple of days, on Monday, we looked at moving our magnets closer and closer to one another, showing that when we brought our magnets closer together, we transferred more energy in the system. That potential energy was stored until we let go. And when we let go of our magnet, that potential energy converted into kinetic energy, so causing that kinetic energy to move our magnet. When we brought our magnets closer to one another, we saw that that potential energy was greater, which then meant that our kinetic energy was greater and caused the magnet to travel a greater distance after we released it. Our first key concept that we want to write down is key concept number 7. Moving a magnet against a stronger magnetic force transfers more energy to the magnetic field. So as we brought our magnets closer and closer to one another, we were fighting against a stronger force, transferring more energy into that magnetic field. And then we saw the potential convert to kinetic. At this point, please pause the video so that students can copy down key concept number 7. The next thing that we looked at was on Tuesday when we were using our sim. When we used our sim, we placed our magnets side by side, transferred the sensor in between them, and we saw that as our magnets got closer, as our sensor got closer to each of the magnets, that number on the little sensor increased over and over again, increasing from 8.1 the first time to 27.6 the second time, to then 124.3. As our magnets got closer and closer, we saw that the force around that magnet increased. So our next key concept that you're going to write down is key concept number 8. A magnetic force is stronger closer to a magnet. Again, please pause the video so that students have a moment to copy this concept down. Your mini books will get collected while you are working on your evidence cards later on in class. Now, for your evidence cards, we are going to progress through these together. We're going to talk about them together. You are going to be using these cards to help us understand why the spacecraft went so much faster than expected on Wednesday. We were already able to say that it was not claim 1. Remember, in chapter 1, we looked at whether or not it was that the magnets were misaligned on Tuesday. And we realized it wasn't that the magnets were misaligned. We got rid of claim number 1, stating that was not true. In chapter 2, we looked at how the energy was transferred into the system. And we did confirm there was more energy in the system on Wednesday than there was on Tuesday. We confirmed that because if we see a greater kinetic energy, meaning it moved faster, there had to be more potential energy in our system. So we know claim number 2 is good. And the last couple days we've been working on claim number 3 was that it was the magnetic force that was much stronger. There were 2 arguments. Claim A was that the force was stronger because we moved against a stronger magnet. And claim B was because we moved closer to the magnet, which claim B we confirmed yesterday. There is more energy, there is more force closer to a magnet. While we really did not do too many experiments with the idea of a stronger or weaker magnet, we will be looking at evidence for that claim today. What you have received at this point is a paper or a packet that has 5 different evidence cards on it. Evidence cards A through E. We will work through evidence card E together to make sure we're understanding what it is that we want to be looking at. And then you will work through evidence cards A, B, C, and D to try and figure out what the card is saying and then also whether or not it is supporting claim number 2, claim 3A, or claim 3B. Because at the end of all of this, we want to be able to tell our scientists, this is what happened to our system on Wednesday. Now, your evidence cards are a packet that has evidence cards A and B on the first page, C and D on the back, and then we have evidence card E as our last page. If everyone could turn to evidence card E, we're going to kind of work through evidence card E together. Evidence card E says, this is the energy used to push the spacecraft to the initial position for each launch. So I'm just going to read. During the setup process of each launch, the USA scientists recorded how much energy was required to push the spacecraft to an initial position of 4 centimeters away from the launcher. Remember, when we're actually putting our magnets in place, our magnets want to repel. We're pushing them closer and closer together. That is going to transfer that energy into the system because we're working against the magnetic force. Now, the reason that we're always going to be looking at 4 centimeters is because we want to make sure we're isolating our variable. Since we want to know whether or not the energy was different, we need to keep the distance the same. When I look at this evidence over here, I see on Monday, it was 320 kilojoules. On Tuesday, it was 320 kilojoules. And on Wednesday, it was 320 kilojoules. So what I was able to kind of evaluate on my own by looking at that, I was able to say that the initial magnetic strength is the same each day. Okay, so I'll actually make this a little larger for you guys so that you can maybe see it a little bit more. But I want you to go ahead and copy this down on your card. I notice when I'm looking at this data here and this data here and this data here, when I look at all 3 of those, I'll make those a little neater for you. But when I look at all 3 of those data points, all 3 of those numbers are the same. So our initial magnetic strength for each day, Monday, Tuesday, and Wednesday, was the same strength, 320 kilojoules. Go ahead and pause the video so that students can copy down that the initial magnetic strength is the same each day. So now that I've kind of summarized what this data is showing, I know that the strength was the same. So what does that mean? What does that mean if I'm saying the initial strength is the same? What claims does this maybe support or refute? Again, when we look at our different claims, we have claim 2 is that there's much more energy in the launcher system on Wednesday than Tuesday. We have claim 3A, that the magnetic force was stronger because we use a stronger magnet. And we have claim 3B, which is that the magnetic force was stronger because we moved closer to a magnet. When I read all 3 of those claims and I'm thinking, okay, magnetic strength is the same, I'm starting to figure out if it's connecting to something. Because connecting a piece of evidence to a claim means explaining why the evidence matters for this claim. So in this case, since the evidence shows that for all 3 test launches, the energy required to push the spacecraft was the same, I'm trying to connect that to a piece of evidence. So since 3A says that the magnetic force was stronger on Wednesday because the magnets were stronger, I'm starting to question that. Because if the magnets were stronger, we learned this, if magnets are stronger, it's going to have more energy needed to get our spacecraft in place. But more energy wasn't needed. The energy was the same. So I'm actually looking at this going, wait, that doesn't make sense. That's actually refuting or saying claim number 3A is incorrect because it's not a stronger magnet. The energy needed was the same. So it wasn't that we had a weaker magnet one day and a stronger magnet the next. If the energy was the same, then our magnets always had to be the same. So what I'm going to write here, after I've connected all of this, I'm going to say that I'm able to refute claim 3A because that would say because the magnets were the same strength, okay? And then I'm also going to look to see whether or not it's supporting anything. And based off of what we're talking about, I'm going to say support nothing. So this card was beneficial because it told us that 3A was incorrect. Okay, so get rid of 3A. It doesn't do anything to support anything, but it did get rid of that idea of 3A. Your job is going to be to go through each of the 4 remaining evidence cards and do that same thing. For each card, I want you to make sure that you are summarizing the information that is on the card. And then I also want you to tell me what claim or claims the card supports or refutes. Remember, support would mean it's evidence in favor, saying, yes, this is true. Refutes would say, nope, let's get rid of it. On Monday, you are going to be doing your final writing piece. Your final writing piece is going to be to Dr. Shapiro about what actually happened to our spacecraft. So we want to make sure that we have all these evidence cards understood and evaluated, supporting us for Monday's writing. While you are working on the cards, your mini books will get collected. Once you are finished with your cards, please put them in your folder and make sure you have them for Monday. They're going to help you understand what you're to write about on Monday. So evidence card A is going to be evaluating the distance. Evidence card B is going to be looking at the average speed, which means you're going to be looking at kinetic energy because we're talking about speed. Then evidence card C, you're going to be looking at the energy needed to actually move them into place. Evidence card D, you're going to be looking at the actual launches, kind of like what we did in our sim, only this time you're going to not lock them both and you're going to let them launch and take a look at what happens. So evaluate each one, summarize each one, think about what claims it may or may not support. Can you get rid of anything so that you're ready to do your writing on Monday? I hope you guys have a great day. If you have any questions, ask Ms. Hubley. You can ask Ms. Arispe if she's in the room. You can ask quietly the person next to you, but I do want you to be completing this independently so that you're ready to go for your writing on Monday. If you have any questions that no one can answer, I can take a look at them on Thursday when I return. Have a good day, everybody, and I will see you on Thursday.